just recently and left because I told you it was lunchtime. I'm very sorry. This is not lunchtime. I was going off of yesterday's schedule, and today is different. So yeah, welcome to our actual talk before lunch now. We have Pann here to talk about scaling mobile test automation with Appium and AI, of course. So thanks, and let us know what you have to share.
Okay. Hello, everyone, and thank you for being here today. I am Pann. I'm a QA engineer at KINTO Technologies, a Toyota Cruise-based company focused on mobility services. Today, I want to share a very real and very honest story. It is about how our small QA team went from drowning in task maintenance to building a scalable AI assistant automation test framework with Appium. I will share what worked, what completely failed, and the most importantly, the lesson that might save you from making the same mistakes we did. Here is our roadmap for the next 40 minutes. The breaking point. The moment when we realized our process could not keep the pace of development. Framework evolution. The architecture decisions that build the foundation for everything else. AI integrations. What actually works with AI tools like Claude, GitHub Copilot, and DevinAI. And the fourth is from tools to culture. How we went from a team that said AI is useless to one that uses AI tools daily. Visual regression testing with AI, a newer initiative I'm really excited about. Real impact and takeaways, real numbers and actionable items you can bring back to your teams. So let me take you back where the story begins. The first one is the breaking point. Let me paint the picture for you. At KINTO Technologies, we have two major mobile applications, both service in the Japanese market, both in iOS and Android versions. In total, we have 128 test scenarios. Now, 128 might not sound like a lot to some of you, but here is the catch. Each project took every 6 hours to run a full regression. That is 12 hours total. Half a day, every single moment, we needed confidence that a release was ready. And who was managing all of this? Just only 2 QA engineers. 2 people responsible for test maintenance, test creation, result analysis, and reporting across 2 projects, 2 platforms. We have flaky tests constantly blocking releases. We are spending 6 hours every single week just for test maintenance. Not writing new tests, not improving coverage, just keeping existing tests alive. There are no time for new tests. And we have a serious dependency risk. If either of us was sick or on vacation, the entire testing pipeline could stop working, and it was not sustainable. So these problems show up as 3 concrete release blockers. The first one is flaky tests, unstable and reliable test results. Tests depend on specific environment states and timing issues. Every time a test builds, someone had to check manually whether a test is a real bug or just flakiness. Second, slow feedback. Slow feedback from CI/CD pipeline. When our pipeline takes 6 hours, developers stop waiting for results. They skip waiting and just merge. We have incidents where batch shift to productions because the developers do not wait for test results. Third, the cause of delay. Motivate cause came from release delays, slower delivery, and declining morale. So something fundamental have to change. So we decided to rebuild our foundation, now from scratch. We do not have that luxury, so but systematically, piece by piece. The first and most impactful change was refactoring our Appium framework into a truly modular page object model. For those who may be less familiar, a page object model is a design pattern where we create separate classes for each screen in our application. Instead of writing test code that directly touches pattern and test fields, we created a page object model that knows how to interact with that pattern. What we did was modular Appium framework refactoring, page object plus component design, and a shared iOS and Android abstraction layer, and then a reusable component library. The result was dramatic. We reduced test duplication by over 40%. Cross-platform code sharing reduced our maintenance burden significantly. When a UI changed, we typically only needed to update one or two selector definitions, nor rewrite test logic across multiple files. With a cleaner framework in place, we turned our attention into CI/CDs. We integrated everything into GitHub Actions. So let me walk you through the actual workflow with 4 stages. First, the build stage. Maven validate and confine with dependency caching. Second, the mobile test stage. Download the application file or APK file. Then emulator or simulator plus Appium to run the test. Both iOS and Android are all automated. The third one is code quality. Import check and dependency analysis to catch structure issues early. Fourth, the build summary. A status report is generated and a Slack notification is sent to the team. The pipeline triggers on push to develop or main, on pull requests and through manual dispatch. We also added an AI leveler that automatically tests on PR when AI tools are used in the code. This gives us visibility into how much AI assistant code is entering into our code base. Let me explain our Smart Ruby strategies in more detail. We have 2 modes. The first one is PR triggered, fast feedback. It runs our Go Smoke test suite only. The Go Flow Smoke test. This gives fast feedback by every PR, and every PR is auto-triggered. The second mode is full regressions, deep coverage. Tests are grouped into features into test suite. It covers all scenarios across both projects, organized into feature-based test categories. This is triggered by manual dispatch or merge to main. This two-level approach solves our problem. Developers were no longer waiting for test result and feedback. Let me show you the before and after. Before the transformation, most of our week was consumed by test maintenance and CI/CD firefighting. Our test suite was full of duplication. The same flow were re-implemented across projects and platforms. Flaky tests are constantly blocking releases. And with only 2 QA engineers, that entire pipeline depended on both of us being available. After the transformations, our combined maintenance and CI/CD efforts reduced by over 70%. The duplication was eliminated. Tests became stable and release became reliable. Just as important, the shared framework and documentation meant that anyone on the team could now contribute to the test suite. These are actual measurements from our team. And this framework created the foundation that made everything else about our AI integration. Now, let's just talk about our AI integration. I'm going to be completely honest about what worked and what completely failed, because I think the failures are actually more valuable for you to hear about. Let me start with the wins. We use Claude for log analysis and failure summaries. When a test fails, Appium generates very long logs. Claude does log analysis, identify the cause, and give fix tips. Previously, a QA engineer would spend 50 to 20 minutes for reading logs. With Claude, we get a focused analysis under 1 minute. We use GitHub Copilot for test code refactoring. Copilot gives refactoring suggestions and auto-generated template code. It was very good at suggesting the right patterns when we are restructuring our page objects. The last one is Devin. We use Devin for automated documentation. Devin auto-generated documents from our Appium code. Method descriptions, parameter explanation, usage examples, all derived directly from the code. Each tool found its niche. So none of them was a silver bullet, but it generally added the values in its specific area. So let's go to the failures. These are significant setbacks. So the first one is AI-generated letters. They would pass locally, but silently fail in CI. The AI had optimized for our local environment without understanding that CI had different configurations. We lost 2 weeks debugging this. Second, over-automated tests. Mass auto-generation of shallow, ineffective tests. They give us false confidence like high test count, low accurate coverage. We eventually deleted almost all of them. But lack of transparency and clear AI recommendations cause trust issues. When we could not explain why AI suggested something, the team rightfully pushed back. Let me put the full picture side by side so we can see the lesson more clearly. On the success side, Claude gives automated log analysis that turn a long manual job into a good focused review. GitHub Copilot became a reliable partner for code refactoring and template generation. DevinAI took over most of our documentation work. These tools generally improve our engineer output every day. On the failure side, AI-generated letter cause real pain. Bypassing locally, but quality failed in CI. Mass generation of shallow tests get us misleading coverage numbers without real safety. The AI itself started to feel like a black box that people could not understand about. Some teammates started using on AI tools rather than using their own judgment. And all of this broke the team trust in the tools within the team. The pattern is clear. AI succeeded when it assisted the human judgment, and AI failed when we try to let it replace human judgment. The decision became our guideline principle for every AI decision after this point. So how did we recover? Two concrete strategies. The first one is validation checklist. We validated AI code before production use. Does the selector work in both Logit and CI? Has it been tested on both iOS and Android? Does the test verify a meaningful user behavior? No short gap, no exception. Second, engineer training. We ran workshops on prompt design and AI review. So we share this information into our engineers, how to ask AI questions and how to critically evaluate the output. After implementing this, our AI-related fail dropped dramatically, and the trust in AI tools actually increased. So this brings us to what I believe is the most important sessions, the cultural transformation. AI adoption in our team was not a switch we flipped. It was a journey with 4 stages. Stage 1 was skepticism. AI is useless. That was the team reaction. And after our early failures, they have evidence to support that view. Next was experimentation. This is where small wins what matter. I'm quietly use Claude for log analysis on my own failure tests and share the results within the team. When my colleagues saw how much faster I'm getting to the root case compared to the old manual approach, curiosity begins to replace skepticism. Stage 3 was adoptions. The whole team started leveraging AI tools, and each person found their own use case and workflows. Stage 4 is culture. Working with AI is no longer special things. It is simply another tool in the toolkit. To make this culture sustainable, we invested in internal standards and community engagements. We established AI code review criteria for code ensure consistency. We developed task quality checklists for team use. We also define AI tool usage guidelines for the whole organizations. We share our experience at Appium-based Tokyo. We did internet blog for knowledge sharing. We are giving conference presentation like this one today. And the QA community gets stronger when we share not just success, but also honest failures. Now, let me talk about something I'm particularly excited about, our visual regression testing. Over the past several months, we have been building a full-page visual comparison pipeline that uses AI to help us to catch the kind of UI regressions that traditionally functional tests simply miss. In the next few slides, I want to talk you through how the pipeline works, which AI tools rely on for each part, and the result we have seen so far. So, visual regression testing compares screenshots of our application against the baseline. If something changes, a button moves, a font changes, a color is wrong, the test detects it. Mobile visual regression testing has a unique challenge. We cannot just take a single screenshot. Mobile screen scroll. We have fixed headers and footers. They have dynamic context areas. So we built a full-page visual regression comparison pipeline. It captures screenshots at every scroll position, trims the fixed header and footer, stitches them into one full-page image, and compares pixel by pixel against the baseline, and uploads a highlighted different image. The visual testing pipeline requires a large amount of utility code. And this is where GitHub Copilot proved to be extremely valuable. Copilot's main contribution was code generation and refactoring for all the repetitive glue codes that surround the core logic. On the generation side, Copilot helped us produce template code for our Figma API integration, expose scripts that gratefully handle rate limiting, a set of image processing utilities, auto-completion for our test configurations files, and refactoring supports for our comparison logic. To give concrete examples, Copilot wrote the retry and rate limiting scripts that read every Figma API call. It generated the screen mapping configurations directly from our screen definitions. It produced image scaling helper methods that handle resolutions difference between the pies. It wrapped the stitching algorithm that combined partial screenshots into a single full-page image. And it generated the test suite XML that organized all of our visual tests. Overall, Copilot reduced the amount of repeated code we have to rewrite by around 60%. Claude played a fundamentally different role in this project. It was our partner for architecture and intelligent analysis, not just for code regeneration. On the design side, Claude helped us with the overall visual regression architecture, with the mapping Figma screens to individual test cases, with defining different thresholds that are aware of screen being compared, and with the analysis and explanation of different images after the fact. It auto-generated the screen mapping configurations that connect each Figma screens to the correct data test cases. It also defines the excluded area definitions, the region of the screens, such as timestamps or dynamically changing content that should be ignored during comparison. And it helps tune threshold for each type of screen. So a login screen gets a tight threshold, while a dynamic feed screens get more tolerance. On top of that, Claude analyzed the different images themselves and explain what is different in plain language. We saved enormous time during review. I would like to summarize the division of labor in this way. Claude was the architect. Copilot was the builder. So both are essential, but neither would have been sufficient on its own. The third P is Figma API. Design at the source of truth. What the Figma API provides, it exposes design as PNG baseline. Screen IDs are invented in Figma names, creating a dry mapping between design and test. It supports page-based filter export, so we only export the screens we need. It includes map retries and rate limiting. And it auto-detects one design change in Figma. The integration benefits are significant. No manual baseline maintenance. Figma equals the expected UI truth. Design changes are auto-detected and reflected in tests. We can do filter export by page or frame. So we got consistent cross-platform baseline across both iOS and Android. When a designer updates a screen in Figma, our pipeline automatically picks the new baseline. That is what I mean, design driving destiny. So let's wrap up with the real measure impact and the takeaways you can bring back to your teams. Here are the headline numbers from this journey. The first number is 70%. This is how much we reduce our overall maintenance and CI/CD effort. Our QA engineers went from spending most of their week just keeping existing tests alive to actually having time to improve quality and build new things. The second number is 30%. This is the speed we achieved in our CI/CD feedback loop. Developers now receive meaningful test results fast enough that they can actually act on them, rather than merging fast and finding out later. The top item is qualitative, but it is just as important. A clear improvement in release reliability and developer trust. Behind these headline numbers, all 4 of these release blocker we status are now resolved. The flaky tests have been stabilized through smart retry and environment isolation. The pipeline itself no longer blocks releases. So we have reclaimed the weekly maintenance time and that used to disappear into upkeep. And the key person dependency has been removed through a shared framework and proper documentation. So if anything in this talk resonated with you, there are 3 things you can take back to your own team right away. The first is test suite audit template. Before you change anything, take a hard look to your current suite and evaluate its quality, its actual coverage, and the hidden costs you are paying for it. Because you cannot improve what you don't measure. The second is AI guidance checklist. If you are already using or planning to use AI assistant code generation, put a validation process in place. Before the code error enters your pipeline, the single habit prevents almost every failure mode I described earlier. The third is refactoring starter kit, a step-by-step guide for framework improvement. I would suggest starting by modularizing your page objects, then triggering CI/CD once the framework is clean, and only then layering AI integration on top. AI on top of a massive framework just gives you massive failure faster. So let me close with 5 key takeaways from everything we have covered today. The first takeaway is refactoring your Appium framework for scalability is not optional. Without a clean modular framework, no amount of CI/CD tuning or AI tooling will save you in the long run. The second is that Claude, Copilot, and DevinAI, each and their place in a QA workflow. But only when you use each tool where it is generally strongest, rather than treating them as interchangeable. The third is that AI tools have really and specific failures modes. And knowing those risks before you run into them is what separates a productive adoption from an expensive one. The fourth is that checklists and review processes are what make reliability sustainable. And keep maintenance from coming back in. They are the safety nets that lets a small team foster with confidence. And the fifth is that the real goal is a scalable culture that balances automation with human judgment. So I would like to leave you with this talk. Each tool we adopted, each project we built, the goal was never to remove the human effort from the loop. It was to remove the time-consuming tasks from the human state. So we could spend our energies on the decisions that truly matter. Thank you very much for your time and attention. Whether you are just starting with Appium, exploring AI tools, or dealing with the same scary challenges we faced, I would like to hear your stories too. Thank you.
Thank you very much. That was a super interesting talk, and we have a lot of time for questions, about 9 minutes. So yeah, I'll bring the mic around.
Hi, you did an awesome job. My question is, how long did it take you? And is there something that's obsolete now, since the world's moving faster and faster?
Sorry, could you please again?
How long did it take you to set up these changes?
Yeah. I think 3 months. Because the first one we have to change the foundation, we have to build the foundation and then change our workflow with AI. So and then we have to keep on this process. So I think the whole process is about 3 months maybe.
Okay, and is there anything that's obsolete now already?
Can I share you later?
Yeah, sure. Yeah, thank you.
Thank you. Thank you for your questions.
Hello, thank you for the really nice presentation. I have a couple of questions. First one being, what are the technologies that you were using for your framework other than Appium?
Appium framework, TestNG.
TestNG, okay. And the second question was, what metrics did you realize were showing you how much, like you mentioned about guardrails and stuff. So what are some actual metrics that we can say that these are what define better code quality generated by AI?
Could you please again?
Some metrics like identifiers that you can say help you identify the problems within your code and whatever you're doing.
Sorry. Maybe so sorry for maybe I misunderstand for your questions. So the first one is if I misunderstand, you can tell me later. The first one is when we use GitHub Copilot, so it gives a false element locator. So we realized that one, and then we have to use carefully, and then we have to check again and again. So I mentioned it fail. Sometimes it fails. So does it make sense?
I can talk more.
Okay, thank you.
Yep. Sorry.
Hi, thanks for the presentation. One of your slides mentioned that you have reduced the runtime of the tests by 30%.
Yes.
Do you run tests in parallel or in a single session?
Yes, we have two workflows, iOS workflows and Android workflows, and we execute this in parallel.
Okay, thank you.
Any other questions? Yep. Okay.
Hi, I'm not sure if I got this from your talk. You were asked how long you took. How large is your team that did that? Or did you do it by yourself?
because in our team we have just only 2 QA engineers, and then I am sub leader, so I have to set up time schedule, and then I have to report how much we spend time duration. So I have to report my leader, and then it lasts about 3 months before I mention. Because just only do QA engineer is insufficient to do the whole thing, right? Yeah.
Yes, thank you. It's impressive.
Thank you.
Hey, you mentioned that you are combine resources for both platforms, for iOS and Android. Do you have a browser test as well, or not? Classical browser test like in Safari, etc.
No.
Desktop test. Yeah.
Sorry. Now we are testing just only mobile application and Appium. So, for example, we before we use expert for element locator in Android, and then iOS we use ID element locator. It's separately before. So we have to spend a long time for execution because they are separate element locator. So we change to use the same element locator like IDs. So we have to tell developers we would like to change the same element IDs for both iOS and Android, and then we use it. So it reduces our maintenance and test execution. Yeah, does it make sense?
And do you use WebDriver IO, I suppose, too?
For both iOS and Android.
Thank you.
Anyone else? No? All right, well, let's give another round of applause to Pann. Thank you very much. And now it actually is lunchtime. In case you missed the announcement earlier, if you submitted a lightning talk, you have been accepted. So don't miss the lightning talks. All right, have a good lunch, everyone.